Tips, and then we create a project for today. 114, good. Okay, so let's create a new project first. Okay, let's call that new Java project, and then CSE114 Spring 16, and then Week 15 Lab1. Okay, that's a project for today. Today we're mainly going to try out the two examples which I briefly talked about last Friday. So just to give you some more clear idea about what exceptions really are. And then I'll give you exercises to do, which will take some time, and also some time as well on Wednesday and Thursday, and then go for solution at WN for the semester. Okay. It's sad, right? Very sad. Yeah, we are going to an end. Okay, let's now do the very simple example here. Okay. So let's create a class. What about create packages, since we got only one session this time, so just keep the code more organized. Let's create a new package here. Let's just call that circle. Okay. So we're going to see how things might go wrong in the case of a circle. Okay, let's say we have a new class. Let's just call that circle. Like that. Okay. And for the circle class, very easy. We just have one attribute for radius. And the fact that we declared this radius as double, which means it might go as negative, positive, or 0. Okay. However, we shouldn't allow for negative value of circle for its radius value, but we'll see. Okay. For the constructor, let's say very simple. So remember, in Java, if you do not explicitly declare any constructor, there will be a default constructor available, right? So we do not explicitly declare the constructor for circle, meaning that the default one will be available. For example, in the tester, you can simply say circle and then C assign to new circle with empty parameter list, which will simply just give the default values to every attribute here. In this case, we got only one attribute for this circle, which is radius, and it will be assigned the default value 0.0. Okay, good. So now let's have some mutator here. Let's say mutator method for radius. Okay. So now let's say for that one, it's going to be a void method set radius to some new radius. Let's say we have the same name, double radius, and we learned from before to disambiguate, you will use a this keyword, right? You would say this dot radius is assigned to radius. But this is not good enough, because in the case where you pass the radius value as -3, we do want to print out some error message to the console as we did before. Let's try that first, and then we'll illustrate that it is not sufficient still. But let's try at least better than nothing. Let's try something first. So let's put a comment here. A negative value of radius should be considered as invalid. So, which means we should do something about it. So here we'd say if the radius is less than 0, then we should really print out some error to say system.out.println to the console. That's our first solution. Okay. We can say error negative radius. Otherwise, if the radius happens to be non-negative, we can set it like that. Okay, so nothing too complicated so far. We have a mutator method for the only attribute we have, and then whenever we pass any negative value for the radius, we should print out some error to the console. Okay, and let's also have an accessor method here, which will calculate the area for the circle. Okay, let's say accessor method which returns the area of circle. Okay. Yeah. Okay, so now let's say double because the radius itself is double. So double get area. Sorry, let me just make sure I'm recording. IN, yes. So now we have get area here. So now what should we return? We can first of all declare a variable of the same type as a return value. Double area initially 0.0, eventually return the area. So now how should we calculate the area? Just radius squared times pi. There are two options here for the pi. You can either declare a constant over here to say final double pi, which is assigned to 3.14 whatever. Or we can use the pi from the math class, which is much more precise. We can try that this time. Okay, it's really up to what you need. So let's say area is assigned to radius times math dot pi. If you want to make it even fancier, rather than saying radius times radius, you can say math dot power. You can say radius to the power of 2. It's not really necessary, but I'm just showing you got more than one way to write the same thing. Okay, equivalent to radius times math dot pi. Yeah, at least you got this, these two possibilities to write. Of course, sometimes you may want to calculate the formula may be something to the power of 10. In that case, the PAL method is much more useful than writing the same multiplication 10 times. Right? Okay, so far so good. Let's try a tester to see how this solution here is still insufficient. Let's see. So now let's go back to the Explorer here. Let's create a new class, circle tester. Okay, with a main method here. Finish. Let's try normal case. Circle C1, new circle. Okay, so far so good. That's using the default constructor as I said before. And then we can say C1.set radius to be, let's say, what about just 10? Okay. And now if I say C1, let's say area, double area 1 is assigned to new, assigned to C1.get area. And then I say system.out.println area of C1 is plus area 1. Okay, very easy. So we set some legal value to the radius of C1, and then we try to calculate the area and print it out. That should be like a 10 times 10 would be 100 times 3.14 whatever. So let's see. If you run it, it's going to be something like that. Okay, that makes sense. Okay. So now let's try something that's illegal. Okay. So let's try to create another circle object. Circle C2, assigned to new circle. A completely different object. Okay. If I say C2.set radius, now I'd say minus 10. Apparently minus 10 is illegal. Agree? So what our code is going to do is to go to the if branch and print out some error message to our console. Let's double check with this before we go any further. Okay. So let's now do launch. Here you can see somehow we say error negative radius. Okay. A sensible next move is to let a user to either retry to enter just another radius or to do something else. But the bottom line is we should not set the minus 10 to be, well, we shouldn't actually continue with any circle calculation with this kind of illegal value, right? That's the bottom line. But let's see what's going to happen here. If I say over here, if I do something similar, let's say double oh sorry, I say C2 dot, oh I got that one, double area 2 is assigned to C2 dot get area, and then I would say system.out dot print line. Area of C2 is plus area 2. You know what? I can make it even more dramatic. Okay, let's try this one first, and then I'll show you another one. Okay. So in this case here, we knew that from line number 11, we are trying to set a illegal value of -10 to C2.radius. We know that it's going to print out some error message to the console, which we saw already. However, the code, strangely, is still going to execute this C2.getArea, which is not right, because we know that the area has been, the C2 has been set with some illegal value of radius, so it shouldn't continue. It shouldn't. You should really report the error and stop the user from executing the code anymore. Let me illustrate the point to you. Can we just put a breakpoint over here? Line number 10. Okay, that might be the easiest. So now I would just want to say run debug as Java application. So now I stop here. So this is the line where I'm going to create C2, which is okay. And now let me step into C2 that set radius -10. If I step into it, I will see that now I am in set radius method here. And because radius, which is -10, that should go into the if branch. And we do actually print out some error message here to say error -radius to the console. So far so good. But let's see what happens afterwards. So now we finished executing this line here. So now we're just about to execute this line. But we already saw there was an error message printed out to the console. So we should not be allowed to execute this line anymore, right? But somehow we are still allowed. So that's the problem, okay? So now let's see what this line is going to print out. Okay, let's say line number 13. If we do that, it says that area of C2 is 0.0. It seems like a valid calculation because we simply say a circle simply has area of 0.0. But in the previous line, it simply said -10 is illegal. But why can you calculate area? Are you trying to say the area for -10 circle should be 0, or I say something else? So that's really the problem. Let me make the situation even worse. Can we just go back here? And let's try another one. So now let's say C1 dot set radius here. What about I say -5? Again, -5 is also invalid, right? So now I can say area 1 is assigned to C1 dot get area, and then system.out dot print line. And then I can say area of C1 after resetting that to after resetting the radius to -5 is plus area 1. Anyone want to predict what's going to be the output from if I try to execute lines number 15, 16, and 17? A hint for you: if you go back to the circle class and have a look at how we implement the set radius method here. If now I say C1 that set radius, previously we set the radius to be 10, previously, but now we are trying to set it to be -5. And then we are trying to print out the area, right? So what's going to be the output from that level here? Or what's going to be the radius value that's going to be used to calculate the area? And agree? Because in the case of error, we simply don't reset the value of radius, right? Again, that's even more wrong than the previous one. Okay, let's try that. Very good. Let's go to circle tester here, and then let me just execute the code. You'll see somehow in the case where the C1 has been set properly with its radius being 10, we got this value here, 314, blah blah blah. And later on, we actually try to reset the radius to be -5. And then from there, we actually saw that the output is still 314. That's absolutely doesn't make sense. Okay, so now the problem really is, the problem really is that whenever you actually got, I'll document down here for you. The problem is, oh, actually not this line here. Let me just put it this line here. The problem is after we set -10. The problem is the error message is only printed out to the console, but the normal flow of execution is not interrupted. That is, area 2 is still calculated and printed. Okay, that's a very critical point. So this actually gives us motivation to do something different. If you simply just print out the error message from line number 11, it's just going to print it out, but it is not going to stop you from going further with line number 16 and 617, so which is the ridiculous messages we saw before. Remember, when you set the radius to be -5, you still get an area of 314 something, right? But it did not stop you to actually do it. But now with the exceptions in Java, you can actually achieve that quite easily. So that's a motivation. Okay. So this is a very simple example. We'll try to do the solution with exceptions, and we'll try another slightly more complicated example. Okay. That's hopefully these two examples will give you the intuition for exceptions. Any questions so far? We haven't reached exceptions yet, but we are going to see that now. I'm going to show you the steps that you should do. So in general, there are 2 steps for exception handling in Java, just in general. The first step is create an exception class. Okay, the second step is, so here, I already made the slide available for you to study, but I'll try to go over them again on Friday. But there is a very important principle we have to follow. It's called the catch or specify principle. Catch or specify. Okay, so these 2 steps, I'll explain what each of these really mean as I go. Okay, 2 steps. Okay, first of all, the first step is we have to create the exception class. In this case, you can see the only place that might go wrong is when the radius goes below 0. So let's create a new kind of exception for this. So that's like creating a new class. So let's say, so the name is really up to you, but the convention is you should really end the class name with exception. So it can be NegativeRadiusException, or it can be illegal radius exception, or it can be I don't like this radius value exception. It can be anything you like. Let's try the more sensible name. Okay, let's go to this package here. Let's create a new class. Let's call that NegativeRadiusException. Yeah, you really want the name of the exception class to be as informative as possible. Okay. NegativeRadiusException. I think that's informative enough. With no main method. Okay, let's say finish. Okay, so now we're going to extend. As far as this course is concerned, there will be 2 possible superclasses you can put here. I'm going to put the first one here just to avoid confusion. So typically you would just say extends exception. Extends exception. Okay, which means NegativeRadiusException is a descending class or subclass of exception. That's what we're trying to do. And exception here is a predefined class in Java. Okay. Okay. Let's typically the only method you have to write here is the constructor. That's the only method you have to write. Okay. And we can say NegativeRadiusException. and string S, and then super S. So basically, we are trying to call the constructor that is defined in the exception class, and that constructor there takes a string. Okay, we kind of learned about the super keyword from before. I would say you don't have to really memorize this line here. For the final exam, I'm going to allow like data sheets, so you can feel free to put this fragment of code in the sheet if you want. I'm going to talk about this on Friday.
Any fragmental?
Huh?
Any fragmental codes?
I'm still thinking about it actually. Yeah, maybe I should say this is the only fragment of code you can build. I'll let you know on Friday. Okay? There will be some scope data sheet. Okay? So I really want to minimize your memorization. Now I'll talk about it on Friday. Okay, so we got negative radius exception here, and that is a descendant class of exception. Okay. So now, to be more explicit, it's very important to notice this. Okay. Let me put this diagram here, which might seem trivial to you, but we'll see. It is important to see that exception, and we have a subclass called negative radius exception. Okay, like that. Okay, that's the simple hierarchy we're creating. So now let's see how we can use this exception. Since we defined this class here, so the way to use it is by creating an object of that type. And we should go to the place where this kind of error might occur, which is when you have negative radius value. So now we go to the setRadius method here, and we go to where we actually used to get this print statement here. Okay. What about this? Let's create a new version of circle. That might be better. Okay. What about we create a new version? So new, and then class. Let's say circle2. Circle2. Okay. And now let's go to circle here. Can we just copy everything from double radius here until the end, so we can reuse the code? Okay, like that. Let's copy the code, and let's go to circle2. Okay, and let's put some comments here in the very beginning. In this class, we make use of negative radius exception for error handling. Okay, so we got two versions here. In the first version, we try to use just the print statements. In the second version, we try to use exceptions. So now the only difference is, so let's comment this line out. So when the radius that's supplied by the caller of setRadius is negative, rather than printing out the error statements there, we try to throw an exception. So let's say this. Let me do the more verbose way for you. So we say negative radius exception NRE, okay, assigned to new negative radius exception. So here, let me just separate it into two lines. Okay. So we are creating a new instance of the exception. And then here you can say some error message here. You can say error, we can simply negative radius. Or you can even say more, plus radius. You're saying exactly what the value is. So here we are creating a new object NRE of type negative radius exception. Okay? And now this is the new keyword you have to learn. Now we're going to throw it to the runtime. Throw NRE. Okay, let's do this first. So there will be a more compact way to say this, which I'll show you first. And then we'll talk about why the code does not compile. Okay? And to fix the compilation problem, we have to follow the second step, actual specify. Okay? So let's see how we can write in a slightly more compact way. So somehow we don't really need this intermediate variable here. we can simply just use the new expression here, as I explained in the lecture before. So a different way to write this would be you can simply say throw new negative radius exception. And then basically the same thing. Plus radius. So this line here will also work. But you can try that later, okay? Just type it out and I'll put it into comments. Is it okay if I turn off the air conditioner for now? Or because it's really annoying every once in a while. If it gets too hot, maybe I'll turn it off. I guess that's not. If it gets too hot, let me know. Okay, so now let's see why the code does not compile. Let's see why. Okay, let's see over here. It says that unhandled exception type, negative radius exception. So basically it is saying that you're trying to throw a new object of type negative radius exception, but somehow you have not handled that. But what does it really mean to handle an exception? Okay, so there is something also detailed in your slides. It's called a catch or specify principle. So to handle an exception, either you specify the exception or you catch the exception. Either way, but not both. Okay. So let me show you what does it really mean to specify the exception. To specify means to include the exception as part of the signature. To say this method here might throw this exception at runtime. It might. In the case where radius is negative, it will throw the exception. So that's a specify. And catch would be when you actually try to call the method. If the method might throw this exception, I can use a try and catch block. Okay, that's another way of handling it. But let's try the first way first. Specify. Okay, you can try either way, but not both. Okay. Okay. Anyway, that's okay. So now let me just document this. Okay, to handle this exception, either catch, okay, or specify. Either way. Okay, I'll say 1 and 2. 1 and 2. So catch means use the try and catch block, which I'll show you at the second resolution. Okay. And for the specify, that means to include in the method signature that such an exception might occur at runtime, i.e., when radius is less than 0. Okay, let's try the, I'll let you type. And then let's try the second one first, and then we'll try the first one. Okay, so now let's see what we can do. So now to specify that, so now this is the signature for setRadius. You can see there's a return type void, the name of the method is setRadius, and the parameter radius. Now we're going to extend this signature by saying this method here throws. So it's a different keyword rather than throw. Throw is like a verb, right? To say you might throw something. And throws means it might behave like that. It might throw, right? So it's different meaning in English. So you'd say this method here throws. You can change to a new line, say throws negative radius exception. Okay, the compilation error goes away. So in some way, we're trying to handle this exception here. To say from, okay, let me recap what we have done. From line number 20 to 22, we're saying that under the circumstances where radius is negative, we will throw a new object of type negative radius exception to the runtime. But now, following the catch or specify requirements in Java, you either have to specify the exception or you have to catch the exception, either way. And now we are trying to specify the exception. You can see line number 15. We extend the signature for set radius, saying this method here might throw negative radius exception at the runtime. Okay, that's the one possible solution. So the consequence of this, I'm going to write it down. So let me just put a comment here. Here we specify as part of the signature of set radius that at runtime it might throw a negative radius exception. And then now we're going to say the consequence. The consequence of this is that whichever any caller of set. Remember we talked about caller versus callee. So caller means whatever method that's going to call this method here. Any caller of this method here will have to either catch or specify this exception. We're going to see that. Okay, I think that'll be good enough for you to read over later. Okay, let's now go to tester. Okay, let's see how we can do that. Can we just create just another tester, just tester 2? So you got the two versions separate. New. Let's go to class here. Let's say tester circle tester 2 with a main method here. Okay, so now we're gonna create circle 2 objects, not circle. Circle 2. Okay, C assign to new circle 2. So far so good. Okay, so now let's see what's gonna happen here. So we're gonna say C dot set radius. If I say -5, it does not compile. First of all, well, you might think it's okay because we are passing a double value -5 to the set radius, and set radius is defined in the static type of C, which is circle 2. If you apply all the rules you learned before, it should compile. Okay. However, this line here violates the catch or specify requirements that we talked about. Okay. Why? Let's go back to the signature for set radius, which we just did before. If you go to the set radius method there, you can see that in circle 2, as part of the signature of set radius, it says that this method here might throw the negative radius exception at the runtime. That's an exception. And now, in the tester 2, we are trying to use that method. And as part of the rule of catch or specify, you have to either catch it or specify it. Okay, so now that's one. So if you move your mouse over that, it says that on handle exception type, negative radius exception. Okay, let me just put it here. This line does not compile because the set radius method from circle 2 specifies as part of its signature that it might, when radius is less than 0, it might throw a negative radius. Okay? We must follow the catch or specify requirements. Okay, let's see how we can catch. what we did before was specify. Okay, if you simply want to do specify, let me show you this. You can say this. You can say the main method here throws negative radius. Okay, let me just put it here. So now things just compile. It's still the same as the specify approach. Let me put a comment here. Just as we did for set radius in circle 2, we specify that the main method of circle tester 2 might throw in a negative radius exception. So it's either catch or specify. It's really up to you whether you want to use catch or specify. Again, using the specify. Okay. Let's try this. Okay. So now, can we just put a breakpoint over here? Line number 15 over here. So now, if I try run debug as Java application, okay, and then I'll say OK. Okay, now right before I go into c.setRadius -5, okay, now I'm there. So now if I say step into, okay, step into, and the radius is -5. So that means I'll go into this if branch here. I'll create the NRE. So NRE is there. It's a negative radius exception, right? So now I'm going to throw it. Okay. And now somehow it has been thrown. So now this is the outcome over here. So somehow it's being thrown to the main method. Okay. There's something I need to tell you actually. Let me just draw some diagram here. But this some diagram, at least mentally, you have to keep track of. Think about how we actually execute this simple program here. So we have circle tester 2. Okay, and then dot main method. So inside the main method, we create circle 2. C is assigned to new circle, and then we say c dot set radius, and then we have -5. So that's the first block of code we are trying to execute. And then from here, set radius here, we are trying to make use of the set radius method that's defined in the circle 2 class, right? Okay. So now we have circle 2 class dot set radius. Okay, and inside we actually say that if, of course, you got some let's say R here. We say that if R happens to be negative, then you have to throw new let's say negative radius exception, I'll say NRE, and etc. Okay, that's kind of the second block of code. So the thing is, when we first try to execute the main method line by line, when we reach this line, when we say c.setRadius, we have to make another method call, which is this one here. So we are trying to call the setRadius method that's defined in circle 2, right? So inside the circle 2, we say that if the R you're passing, which is -5 in this case, if -5 is less than 0, which is true, in that case, we're going to throw the exception. Okay? So now let me just say here. So this black arrow here means execution flow. So we actually execute the lines in main method one by one. When we execute this line here, we have to somehow go to this line here. Okay? That's what we have. So now, because we know that this line here throw a non-radius exception, negative radius exception. Okay. So what the Java runtime will do is to see who is going to handle that. Okay. So now let me be more complete over here. Over here, we say that remember we said throws, negative radius exception. That's what we said before, right? But also we say that main method also throws negative radius exception. Okay, that's what we said before. So now, once we reach here, so the exception is thrown. So now Java runtime is going to see which method is going to handle this exception. Okay, it sees that this method here only says that I might throw this exception. So that means I have no intention to do any action. Okay, and then it is going to go back to where it was used. It's going to go back. And then in this method here, again, it says that this method here might throw this same exception. So it also has no intention of doing any further action. So it is now going to go to higher, which is just the console. So that's why in the console there, we simply saw the exception being thrown there. It's just thrown directly to the console rather than being handled. Okay? So to understand this even more, let me try to show you different versions. Okay? To see how the exception may be handled. I think that once you understand this simple example here, it'll be much easier. Okay? Now just stay there. Okay. So now, can I just try maybe a different tester? Okay. Okay. Let me turn this off, and then I would like a different version of the circle tester 2. So here we got circle tester 2. Okay, can we got circle tester 3? New class circle tester 3. Okay, which is going to be very, very similar to circle tester 2. But let me just copy the code here. Oh, actually, I don't think we need to. Go ahead. Let's just develop from scratch. You need a main method there. Okay. So now, rather than remember the try catch was specified. For circle tester 2, we did the specify. Now we're going to do the catch to see how the program behavior is going to be different. Okay, let's try this. So let's say circle C2. Let's say C, circle 2. It's assigned to new circle here, and we say C dot circle 2. By the way, why this line wouldn't compile? It's not a descending class of circle 2, right? Don't forget. Nothing to do with exception, but you got to remember that for the final. Okay. Very good. Okay, circle 2 here. Okay, let's see C dot set radius minus 5 still. Okay, so now again, this line will not compile. This line does not compile if we neither specify it as part of the okay, let me just put it in parentheses, as part of the signature of main. Sorry, too many typos. Okay, somehow compile is not one of the words in Eclipse for me, but it doesn't matter. Oh yeah, actually that's a typo here, compile, yeah. So if we neither specify it nor catch it using a try and catch block, okay, which I'm going to show you. Okay, so every time if you want to handle an exception, either catch or specify, either way. Okay, now I'm going to show you how you can catch that, which will require some new syntax. Again, never mind. Okay, it's called a try and catch block. Try is a new keyword, like that. It's like a block, right? You can say try, and then with open and closing parentheses, okay? And then try and catch. Catch, over here, parentheses, and then here you gotta specify the exception you would like to catch. So in this case, I am expecting maybe a negative radius exception. Negative radius exception. and then it's like a declaring like a method. I would say that let me call that exception maybe just NRE. And here, action to perform when handling the negative radius exception. Yep. Let me put this line here. Okay, everything compiles. So I would like you to later on contrast circle tester 3 and circle tester 2. So they represent the two possible solutions you can impose when you want to handle line number 10. Again, line number 10 might throw a negative radius exception at runtime. So you got to handle that for sure. But there are two ways you can handle it. Either you can specify or you can catch. To specify it, you can see that from circle tester 2. The way we specify that is by include as part of the signature of the caller method, which is the main method, to say this method here might also throw the same type of exception. As we saw from the diagram here, if it says that the method is going to throw the same exception, it's going to find out in the next level who is going to handle that, right? Who's going to eventually catch that. If there's nothing there, just throw to the console directly. Okay. But now in circle tester 3, we are doing something that requires a little bit more work, because we thought in the main method here we're trying to maybe pass the negative radius here, so we better check to see what if we actually pass some negative value here. In that case, we have to do something. Okay. Okay, so here we can say system.out.println negative radius, something like that. But now I want you to put some lines here, okay, again, and then c.get, and then I'll show you the difference between this and the very first example we did before. There's a fundamental difference there. Double area is assigned to c.get area, and system.out.println area of circle is plus, and then let's say area. So now, again, you should really compare the three testers very carefully. If you compare this version here with circle tester 1, okay, in circle tester 1, if you're trying to set a negative value for the radius, it is simply going to print out an error message to the console. But now, since this line here is going to throw an exception, so the normal flow of execution is going to be interrupted, which means as soon as I got an exception from this line here, I'm not going to go further. I'm not. Okay, I'm actually going to throw the exception here, and then since we are within a try and catch block, so Java runtime will actually look for the catch block over here, and it's going to try to see the matching exception. So now because the type of the exception that's being thrown is called the negative radius exception, so it is going to match this particular block over here, and then it is going to print out the error message for you, or whatever action is specified over here. Okay, let's try this first, and then I'll recap. Can we just put a line over here, line number 10, and run debug as Java application. So now we're here. So remember the set radius method here from circle 2. It is going to throw a negative radius exception. So now I want you to watch the next line. So once this exception is thrown, we are not going to execute this line anymore. Not anymore. Okay. So now if you say next step, step over, you see? So you actually jump the remaining lines in the try block because an exception has been thrown from this line. So that means you break the normal flow of execution. You will just go to throw the exception and go to the matching catch block over here, which is here. Sorry, which is here, and then it is going to print out the error message over here. So that means in this case, we're only going to say error negative radius without going further to calculate the area, which we did. in circle tester 2, circle tester 1. Is that kind of clear? No? So you got 3 versions of this tester to compare. Okay, the first version, you have no exceptions, just the error message printed out to the console. The second version, we try the specify approach. We simply include as part of the signature of the method to say this method might throw the exception. And the third version there, we use the try and catch block to handle the exception. Okay. So now to complete the diagram, so let me say what the diagram should look like. So that's circle tester 2. So let's try circle tester 3. Okay, so we still have our circle 2 set radius. Oh, actually, let me just start from the top. Okay, so now we got a new class called circle tester 3. Okay, dot main. Okay, and then here we have the same circle 2 c new circle. And then we have c.set radius -5, the same as before. Okay, but now we don't include as part of the signature over here. We don't anymore. So now what we did instead was to say we insert a try block over here. We say try this line here, and then try that, and then we also catch. We have negative radius exception, something here, and then the block over here. Okay. So that's what happens in circle tester 3. And then the circle tester 2, circle 2 is just the same as before. The same as before. So you have circle 2 dot set radius r. Okay, so now that part's still the same. Okay, throws negative radius exception. Okay, and we still have that if then else statement there. If r is less than 0, then we might throw the exception. Throw NRE, new NRE. Okay, so now let's see what happens. When this exception is thrown, let's say we pass -5. What Java would do, again, is going to see if the current method here is trying to handle that. The way they handle that is to say this method might throw this exception here, which is true. So we're going to go back to where this method is called, over here. So now, over here, if we go back to that line where the exception is thrown, over here. So this is where the exception was thrown. Okay, this line here. So now, again, Java is going to see how this current method here actually handles the exception. And the way it handles that is by using a try and catch block, as opposed to just say you might throw it. Okay, so now the exception is just going to stop over here because we say try and catch. So now we're going to execute whatever that's specified here, and then we're done. Rather than just throwing the same exception just to the console. So you can think of whenever you say, again, when you say try or catch or specify. Catch or specify. You can think of this way. Whenever you do the try and catch block, so that means handle the exception now, right away. Right away without propagating further. Okay, like this. So we say that we're going to handle this exception right away without throwing the exception to the console, right? That's as a catch. And the specify version here, so this is specify here, so there's a catch here. So specify simply means let the caller of the method handle this. So which means we are propagating. Okay, let's say in this case here, we're saying that for this main method here, we don't want to handle this exception right away. So let's propagate this exception further. In this case, there's nowhere else to propagate further but the console. So that's why we just print out the exception. Yeah, even for this simple example, I think there are really many things, many details here to learn. Okay, but again, catch or specify, that's really the key. So whenever you include the exception here that might be thrown as part of the signature, that means it's specified. When somewhere along the line, you're going to include a try and catch block. That is the catch option. Okay. Whenever you have the catch option, you're going to stop propagating the exception. Whenever you have the specify, that means you are still propagating the exception. Okay. Why don't we do another simple example? Okay. Another one. But any specific question you have about this exception handling mechanism, I'll try to maybe illustrate the point even more with the simple example. But before I go there, if there's anything else you want me to explain. No? Well, luckily, it's not on Friday's quiz. It's on Monday's quiz. Like next Monday, since we have quiz Monday. Juliana, you right? No. You got to study it. You still got some. And well, on Friday, I'll try to illustrate the points more. Yeah, I think for the exception, we really want to try a few examples, especially the one we did in the lab, to see how they work. Okay, let's try another one. Okay, all right. Let's try another one. And this one is going to be just symbolic. I'm going to say A, B, C, D. Okay. Sorry. Okay, let's have another package here. Can we just call that new package? Let me just call that exceptions. Okay. Exceptions here. Okay. So let's create, let's say, 4 classes. 4 classes, okay? A and B C and D. A, B, C, D. Okay? And we also have one more class called tester over here with a main method. Okay? So now let me just close all the classes on my console. Okay. Let's first of all go to class D. Okay? Class D here, can we just have one single method called a void? So not called it void, I mean called it D here. D here, let's say this method here, which is going to take an integer I. Okay, let's create another class. I forgot to create an exception. Remember, there are 2 steps. Okay, so first step, we're going to create an exception. So new class, let's say DException, which means that exception from the class D. DException here, which extends the exception class. And then here, we're going to just use a constructor. Okay, so we're going to say DException string S super S. Okay. So now, let's say this. If the so now we're in class D, which has only one. So we only have one method here, just D. Okay. So now in D here, we'd say if I is negative, then we're gonna throw new D exception. You can say negative value and then I. Okay. Otherwise, just do nothing. Actually, we can do something here. You can say system.out.println, and then you can say d dot d, and then we print out the value of I. Okay, as easy as that. But now you can see this line here does not compile because we throw an exception here, but we have not handled that. And there are two possible ways to handle it, either catch or specify. Let's say we specify. Let's say we choose to handle the exception that might be thrown from line. Let me not say the line number. From that might be thrown by specifying it, which means this method here would say throws the exception. So in some way, we are propagating. We are throwing the ball to someone else. Who's that someone else? Whichever method that's going to use the method here, it has to handle that, either catch or specify. And the propagation is going to continue until you see some try and catch ball. Okay, we're going to see that. Okay, so far so good. Okay, we just specified the exception. So far so good. Okay, let's go to class C. Class C here. Let's say we have void C and then the integer I, like that. Okay, let's say we have some local variable here. Let's call it D, like that. And then we say D dot D. Let's say some value, just I, whatever value that's given. You can see that this line here does not compile. But why? For the same reason. If you read the error message here, it says that unhandled exception type DException. It is because the D method from class D throws the exception. So we have to either catch or specify it. Okay, you can see that the pattern goes on and on and on. But that's why I created ABCD. I just want to see the pattern. So now let's say we choose again to actually propagate the exceptions to the next level. Okay. So now let's say we say that C here throws the exception. Okay, again, here we choose to specify the exception that might be thrown from d.di. Okay, that line. Okay. Then you can see we're trying to use some method which might throw the exception. So we have two options, either to catch or specify. So far we have only used the specify option, which means we're going to, as part of the signature of the method, we say it throws that particular exception. Let's try one more. So we are now in C. Can we go to B? Okay, class B here. Let's say we have some class attribute here of type C. Okay, now B here, we can say in the constructor of B, we'll say C is assigned to new C. Okay. Okay, let's say we have a method here called B. Again, it's void. B here. Okay, so now let's say this. Again, we try to use C dot C. Oops. And this line here, oh, actually, integer I. This line here, again, does not compile. Again, for similar reason. Because here we are trying to use the C method from this class C. If you go to class C here, as part of the signature, it says that that method throws that particular exception. So that's why, again, we got to either catch or specify. Let's say, again, we choose to specify it. Okay. So now here we say that this method here throws, because the same exception type has been propagated further, right? Okay, if I may just draw you a diagram of what we have got so far. So here, let me just say from left to right. So on the rightmost side, we got class D, and we have method D, integer I, and then we'd say if I is less than 0, then we throw new DException. Okay, so this is the place where we throw the exception. Actually, let me plot here. That's the only place where we throw the exception. And the exception might be propagated. Okay, I just put a green part here. So now, to handle this exception here for this method here, we simply say throws exception. So that's a specify option. So we say that throws the exception. So this is the specify. Okay. So now, if we go to the next class we did, so we got class D, class C, where we got the method C, integer I, over here, and we simply call, I think that we got things like D is assigned to new D, and then we say D dot D, and then I. Okay, so now you can see that over here, this green part can be related to this part here. Because the method we're trying to call over there is D. And as part of the signature of D, it says that it might throw the DException. So that is why when you're trying to call that, Java forces you to either catch or specify. Okay, so now, let's say we choose to specify again. Okay, so what we did was, we will say this method here might also throw, throws the exception. So again, we follow the specify option. So this specify option might just go on and on and on until the point you want to do try and catch. Okay. So this part here. Okay, let's say class B. I think that last class we did. Okay, so now let's say class B, and then we have an attributes there, C, and then we have the method B, integer I, and then we set C dot C I. Again, you can see that over here we're trying to use the method here. And because as part of the signature of that method, it says that you might throw a DException. So again, Java compiler will force you to either try or catch it. So to either specify or catch it, right? So now we chose to specify it. Again, we say the throws, the exception, and then it is specified. So now, like that. That's what happened so far. You can see every time when the point is, every time when you're trying to use a method which might throw a particular exception, you will be forced to handle that, either by specifying it or catching it. Okay, so far we see the most convenient way of doing it is just by specifying it as part of the signature of the method. We say throws that particular exception. Okay, so now, finally, let's get to class A. In class A, we're going to try something different. I'm going to try two possible ways of doing it, okay? So let's go to class A. Class A here, can we have two mutated methods? Let's say A1 and A2. Let's say A first. A here, so let's say we declare B is assigned to new B. Okay. Just I'll just take about another 5 to 7 minutes, and then we'll be done. And then I'll give you some new exercises, which we'll continue to do on Wednesday and Thursday. Okay, so over here we have B dot B. Oh, actually, I forgot to include integer I here. Okay, this line here will not compile for the same reason as before, because method B here throws a DException, so either to catch it or specify it. Okay, so now let me create just another method here. Void A2, integer I, B new B. But now I'm going to use a try and catch. Okay, B.bi. Okay, so now let's try two different versions here. Okay, so now, first of all, in this one here, we'd say we try to specify it. Throws DException. So now this method here compiles because we chose one of these solutions. Okay, so now you can say for A1, we handled the DException from B.bi by specifying it. Okay, so now let's try another one. Another one here. And this one here, let's say we don't want to specify, we want to handle that right away. We'll say try this line here. I'm going to try this line here. Should there be any exception thrown, I'm going to match it in the catch block. Okay. Right. I'm going to say catch DE. Okay, and then here I can say system.out.print line. Okay, I'll just say DE, just whatever exception it is. So you can see A1 and A2, it illustrates two different ways of handling the exception. In A1 here, we handle the exception by specifying it. Okay, let me just try to write for A2. For A2, we handle the DException from B.bi by catching it. This means, okay, for A1, this means the DException objects will be propagated to the caller of A1. Okay, and then on the other hand, this means the DException objects will not be propagated any further. So that's the critical difference between the two ways of handling. Whenever you say specify, that means you're trying to propagate the exception further to wherever the caller is. And whenever you say try and catch, that means I handle the exception right away. A1 and A2. Okay, let's do one more tester and then we're done. To see how the two methods are different. So now let's create a tester here. New class. Have we got a tester already? Oh yeah, that's good. Okay, let's use that. So now let's say this. Let's say A, new, A. Okay, so now one question for you. When I say A.A1, let's say whatever value it is, let's say 3, doesn't matter. A.A2, 3 as well. Now, a very important question for you. Oh, you don't have to answer now. I'm going to tell you the answer. You got to think about it. Line number 6 compiles, but line number 7 does not compile. Okay. Why is that? So the hint would be you have to look up the signature for A1 and A2. Okay. So if you go to the signature in class A for A1 and A2, you can see the signature there is rather different, right? You can see the signature for A1, it says that A1 throws the exception. But for A2 there, it doesn't say anything. It simply say signature just A2, right? The fact that A1 includes as part of its signature says you might throw the exception. That means whoever is using A1, they have to handle that explicitly. And for A2 here, it looks just like a normal method. Although inside the method you try to handle the exception, that's okay. As long as as part of the signature it doesn't say throws the exception, then you don't have to handle that. Okay. Let me write it down. So if you go back to tester here, okay, this line does not compile because part of A1's signature declares that it might it throws. So whichever caller of A1, in this case, the main method must either specify or catch it. Okay, that's about line number 11 not being failing to compile. What about line number 13 over there? This line compiles because nowhere in A1's signature declares that it throws some exceptions at runtime. Remember in A here, you can see A2 is completely clean, right? There's no throws over here, okay? So that's why I created two versions to show you. Okay, now in this tester here, so now we're, yeah. Okay, notice that there is no throws the exception in A1's signature because
isn't it A2 instead of
A2, yes. Thank you. Because it's body of implementation already handles that by using a try catch block. Okay, that's kind of the explanation to actually show you why. There are always two versions of solutions: either try, either specify, or to catch it. Okay, so now how would you fix line number 11 to make it compile? How many solutions do you have? Two solutions, right? Either catch or specify. So now, how would the specify solution work? In that case, you have to specify to say whatever the color of A1 is. In this case, that'll be the main method. So you can declare as part of the main method signature to say it throws the exception. That's one way to fix it. Okay. The other way to fix it is by using a try and catch block over here. Okay. So now, I'll have to write down a solution sketch for you. To make the above line compile, either specify as mains signature, you can say throws the exception. Enclose A.A13 in a try and catch block over here. Okay, so these are the two possible solutions to make this line compile. Let me just try the easier one. Okay, you can simply say throws the exception. Okay. Yeah, we're running out of time, but I think that hopefully these two examples give you some intuition about how you may control either specify or catch, but not both. Okay. That's something you should really try to do before Friday. So for Friday, we actually tried, I'll just explain in the slide, maybe one or two more examples and go over some principles, and then we're done with the topic. Okay. And then next Monday, I'll tell you what to do on Friday. So I'm going to distribute some exercise for you, and try that before Wednesday and Thursday. We'll give you a little bit more time, but not too much on Wednesday and Thursday.